Hello and welcome. I'm Randy Emery with the College of the Sequoias Welding Program in Tulare, California. I'd like to present today's lesson, what is the FCAW process? During this lesson, we're going to look at the variables of the process, take a look at the advantages and disadvantages, and then a short lab session where we'll take a look at some of the basic equipment for the FCAW process. What is the FCAW process? This stands for Flux-cored arc welding. The Flux-cored arc welding process uses a tubular wire filled with fluxing agents and powdered metal. The flux will burn during the welding process and create a shielding gas to protect the weld pool during cooling. Most FCAW electrodes run on DCEN, or DC electrode negative polarity. What are some of the advantages of the Flux-cored arc welding process? Well, it is very comfortable and very usable in outdoor applications. And because it is a continuous electrode, restarts are kept to a minimum. Another very important advantage is that no shielding gas is needed. And the Flux-cored arc welding process also has a high deposition rate and can be easily matched to base metal mechanical properties. Because of the forceful arc of the FCAW process, dirty steels may not need to be pre-cleaned. And this could be a very labor-saving advantage of the FCAW process. Like the other processes we have covered, the FCAW process can be used in all positions. Now a little bit about the FCAW process limitations. Heavy smoke and fumes can be one of the limitations that operators may encounter. This can cause discomfort if the right precautions aren't taken. The FCAW process also can cause spattering problems during the welding process. Because the FCAW process has a slag, it also takes interpass cleaning to properly apply the process, which is a time factor in production. The final limitation is the need to break the tip of the electrode off before restarting. When the FCAW process is used, a small ball of flux accumulates at the end of the tip and needs to be broken off before a restart of a weld is accomplished. I'd like to describe the AWS classification numbering system for FCAW electrodes. The first part is an E, which stands for electrode. The next will be a digit, probably a 7, 8, or 9, and you times this digit times 10,000 to get the minimum tensile strength of the electrode. The third part of the AWS classification system indicates the welding position. A 0 will indicate the welding electrode is used in a flat or horizontal position. A 1 will indicate that it can be used in all positions. And the next part is always a T. And the T tells us that this is a tubular electrode. There will be no other letter in this position. And the final part will tell us the usability and performance capabilities of the electrode. Now we're going to move on to our demonstration portion of this lesson. Now we're out here in the welding lab, and I'd like to show you some of the variables that you may need to consider before you start flux-cored welding or GMAW welding. A little information on the differences between the two. Okay, here we have two different drive rolls. One you see here is from the FCAW equipment. The other is from the GMAW equipment. If you'll notice, the drive roll from the FCAW has a knurled pattern along the outside diameter of the drive roll. This is so it can grip the tubular wire, which is a little bit softer than the GMAW wire. So be sure to recognize this when you do your equipment setup. Another important item to notice on our drive rolls: what size is the drive roll? All drive rolls should have a stamped size on them. Be sure your drive roll size matches your wire diameter. Here we have another equipment variable all welders should be familiar with. Here we have a typical FCAW contact tip. Here we have a typical GMAW contact tip. And two of the things you can see right away is the lengths are different. The GMAW a little bit longer, a little bit smaller thread pattern on them, as opposed to the FCAW, a little shorter, a little bigger diameter with a heavier thread pattern. And one thing the contact tips have in common, they should all be stamped with the size of the contact tip. All welders should coordinate this size with the wire diameter that they're about to use and be sure that it isn't a match. Here we have a typical FCAW equipment arrangement. For our power source, we have the Invertech 350 Pro from Lincoln Electric. From our feeder, we have a LN25, also from Lincoln Electric. The only connection between the two is the negative cable from the feeder is plugged into the negative terminal of the power source. Also, on the front of the power source, be sure to be aware of what mode you are in through the mode selection switch located at the left. We want to pick the very bottom mode, which is CV inner shield, constant voltage inner shield, a requirement of the process. Okay, so we want to select that. We want to be sure our voltage is adjusted properly. We have our voltage adjustment knob here in the center. And then we're going to move up to our feeder, where our wire feed speed adjustment knob is located. Be sure to use the range selection switch located below the adjusting knob to pick either the high or low range. And that'll tell you which color code to use when selecting the proper wire feed speed. Along with that, to power this wire feeder, you must connect the voltage sensing cable from the feeder to the work being welded. That should power up your feeder, and you should be ready to pull the trigger, strike an arc, and start the welding process. Here we have the interior of our FCAW LN25 feeder. Some of the important features a welder needs to know about. The first will be the CC-CV switch. We know from our mode switch in the front that we're in CV mode. So the feeder must match the mode set at the power source. Here we are in CV. Another important feature is our drive roll system. And here we see our ability to change drive rolls with no tools. We just line up the star with the groove on the drive roll and pull the drive roll off. No tools required. Simple reinstall, just reverse it, push it on, and push the star back to the lock position. The next good feature of this feeder is it has a built-in tensioner that the welder needs to realize is right above the feeder, and refer to your manufacturer recommendations for the tension for a certain diameter of wire. And the final issue that we have inside the feeder is be sure to identify the AWS electrode classification. Be sure you know which wire you are using. It is the proper wire for the application. To finish up our notes on the FCAW process, I wanted to show you a few detailed variables a welder needs to consider. The first item on the slide is the tubular electrode. The main purpose of the tubular electrode is to supply filler metal to the molten weld pool. The next item is powder metal and flux. The powder metal from the center of the electrode will transfer to the molten weld pool to enhance weld metal mechanical properties. The fluxing agent from the center of the electrode will serve two purposes. One will be to burn off and generate a shielding gas to protect the molten weld pool. The second purpose is to form a thin layer of slag over the solid weld metal deposit to protect it during the cooling process. The next item is the shielding gas envelope. This shielding gas is created by the burning off of the fluxing agent from the center of the FCAW electrode. Like in other processes, the purpose of the shielding gas is to protect the molten weld pool during solidification. The next item is the arc and transfer modes. All arc welding processes will have the arc in common, which will generate the heat to melt the base metal and the filler metal to create the molten weld pool. The transfer modes noted in this slide refer to the different possible modes. The three very popular transfer modes are short circuit, spray, and globular. The next item is the weld pool. This is another item that arc welding processes will have in common. Some variables to consider are welding technique and travel speeds in an effort to control the weld size. The next item is the weld metal. This is the finished weld bead, which is a dilution of both the base metal and the filler metals. The combination of these two metals should create the mechanical properties to meet service conditions of the weldment. Next we have solid and molten slag. The main function of any welding slag is to protect the weld metal during the cooling process. One problem with solid slag is that it may require the removal during multi-pass welding. The final item is the contact tube. Similar to the GMAW process, the FCAW contact tube is where the electrical connection between the welding power and the electrode take place. Another important variable for welders to remember is to be sure to match the contact tube size to the welding wire being used. These are all the variables a welder needs to be comfortable with when performing the FCAW process. That's all we have for you today. Be sure to stay tuned for our next segment where we'll cover the GTAW process. And thanks for watching.